This is one of two presentations we have to help constrain what it means when we say the word research. The other presentation gets more into defining it, while this is more discussing some applications of research. The problem we face is anyone can say, hey, I'm doing research. So often in the business world, people will constantly say, I'm going to research something. And students will often say, I'm going to go research something. And that has a very different context, say, in corporate research and development or academic research when we say we're doing research. So we'll get into that. We'll get into some of the timelines of research which students have a misconception on, and talk about different ways that we can formalize a research question and a little bit about the interdisciplinary nature of research. To start off with, the diagram that I'm going to show is not always very crystal clear of what it means to say we're doing research, because there is no research police who come and slap your hand if you are abusing research. So it's a very peer-driven process in determining whether you're actually doing research. But kind of the kernel of any research question is that we make some observations, we make some opinions, and often we do a lot of background reading on the discoveries of other people. But we can't always eliminate our biases, whether that's our own personal bias to say even a bias in a research method at this stage. That's what we start off with, and that scales up to informal research. And these boundaries are not always clear. But with informal research, which is what you'll typically find in a business setting, is you put more energy and effort into the process of trying to come up with a solution, but it doesn't have the formalities of the next stage in this process. So speed is more important with informal research, and it's not considered critical that we eliminate as many errors or bias as possible. And when we take that to the next step, informal research is kind of contrasted against the formal research we do in private research and development and the academic research we do at universities or that governments may support. So what's the difference here between, say, private R&D and government academic research is you're going to have outside peer review, and in government academic research, you're going to follow the research protocols of those peers. While with private R&D, you can make your own protocols. You don't have to use outside peer review. You might use internal peer review, but again, these boundaries are fuzzy because if that private R&D relates to a research question that is regulated by the government, say a pharmaceutical company, then suddenly those boundaries between private R&D and, say, the expectations of academic research get fuzzy because those regulations force their hand for outside peer review using outside protocols. For a lot of private R&D, they don't want to share any information. They want to keep things quiet because they don't want a competitor to get their R&D results and potentially copy their product, get information that gets a product to market faster than they can. Throwing some arrows against this, again, this is very generalized, that we can go from simple to complex, something that takes days to a decade, and decade can be a common time frame for some academic research, slow and fast. So let's take slow and fast on this diagram and then take it to the next slide, which we're going to go over, kind of erasing some stereotypes students might have about how research works. So academic research, it can be half your time is just reading the background research of others and trying to understand it. And the other half of that is adding your own findings. And we contrast that against business research, where you want to find the best answer right now, even if it ends up being wrong. And there's a saying in business that you should get ready, shoot, then aim. And the analogy there is that you just don't have time to aim. You just have to act before you have all the information that you need, which is very different from how research and academics might work. A common theme when you're a student at an institution and engaging in an internship or a research question is you have to own the project. It's not necessarily a job where you're doing busy work or you're working completely at the direction of what someone else tells you to do. So in academic learning context, it's expected that you're being mentored and that you have some decision over what work gets done, separate from whether it might be a paid or unpaid experience. Looking at the basic tools of research in a business context, it could be only days and weeks to do a literature review. In most academic contexts, it takes months, and that's just an ongoing part of the research, is you're constantly reading what others have done. Parts here, purposefully have them separated. is you're going to collect data and you're going to design an experimental protocol. And for a lot of brand new students to research, you will often join up on a research question where the experimental protocol has mostly been figured out. And the reason for that is so that you can accomplish something in less than a year or a year time frame. If you have to design the protocol and figure out a way to collect data or find the data, analyze the data, it can take easily several years to bring a research question to completion, but it all depends on the context of your research and the discipline of your research. So in one setting, it may take years to come to conclusion. In another setting, a different academic discipline, it could take less than a year. And there are no shortcuts to building up your background knowledge. A lot of students feel there are shortcuts to building up that expertise of being a researcher, and that is what graduate school is for, is purposefully just takes a huge amount of time to build up an expertise to understand completely how research operates. Instead of focusing on abstract concepts of research, we have a few examples from the clinical, hospital, or biomedical side to kind of step us through how this might play out. You can pause and read everything on the screen here. And a showcase is everything can start out with just an observation. And your goal as a researcher is to make sure you eliminate any potential sources of bias and figure out a way to confirm your observations and develop a research question around your observations. So in this case, pediatric cancer patients have to go to the hospital a lot and they're not having a fun time. The nurse manager and psychologist on staff might determine, hey, let's informally see what's going on here. And they might design a survey to see are their observations correct. And if their observations are reinforced to be correct, then they might talk to some other hospitals and maybe share the same survey and see if those results match up with what happens in their clinic. Once you reach that stage, you've invested some time into your research question, and you're investing enough time to decide, do I want to take this to the next level? Do I want to apply for a research grant or conduct a research study that might take several years? So that informal research is there to help us decide, are we going to go for it to the next level? And when we take it to the next level, things get very interdisciplinary and interinstitutional, where often they're going to rely on lots of areas of expertise from lots of different institutions to bring that research question to completion. And the reason there's a doll on the screen here is therapeutic interventions. Most students wouldn't think in a clinical setting about music or art or dolls, but a lot of therapeutic interventions in these settings go back to things like art and music. And students who have, say, very medical interests would not think that those researchers might be pairing up with someone who has a skill set in play therapy. And ChemoDuck, you can go to the website as an example of a potential solution to this research question. So all the boxes on here are different academic departments that might get involved on that type of research question, where each of them is going to contribute a different skill set to come together to answer that research question, because no one person could answer this question by themselves. It's just a lot of research questions take a diverse skill set and a broad team to come up with a solution. So I want you to see there's a tube coming out of ChemoDuct there with a little blue end. So cancer patients and patients who are in critical care, intensive care units that are getting a lot of intravenous drugs have an IV line permanently installed in their body. And that IV line hangs out of their body and has a cap at the end that can get dirty. In this other example, the company and hospital clinical staff made observations that, geez, the end of that cap might get dirty when the people are both at home wearing it and in a clinical environment, say they are hospitalized. So we might make an observation, I wonder if the end of that gets dirty. We might do some informal research just to test the end of the caps to see indeed, is there an excessive amount of germs on the end of it? They might prototype some primitive caps to see if they help prevent those pathogens from getting on the end of it. And from there, you scale up. In this case, it would be a partnership between, say, a private company's research and development researchers and then the hospital staff working together, where the R&D might contribute the manufacturing engineering expertise, biomedical engineering to make the product, and the clinical staff tries to help figure out, does this work in the clinical home environment? You can go look at the website for this company to learn more about what they do. Again, all these different disciplines might come together to solve that research question of, does this product actually work?